take the topic name, some basic principles and techniques of organic chemistry. Okay, see, from this topic, almost all basics of organic chemistry we called general organic chemistry, GOC. The full GOC almost will be covered here. So if you are able to understand this topic, and second PU topics are just equations, all the second PU, most of the concepts like acidic strength, basic strength and other properties we are going to study in this topic. That's what it takes time, but when it is going to be completed, when it is completes everything, so almost on the 50 to 60% second PU chemistry also, organic chemistry also be finished here. Okay, that's what so this topic is very very important to understand organic chemistry. Organic chemistry is nothing but this only. Okay, so second PU organic chemistry is just equations. We have equations, mechanisms, but main basic concepts comes here only. Everything we study here. Okay, fine. Now let us see. Now we have some introduction. See, in olden days, you take the running notes for this. Don't expect no giving notes and all. Okay, right. In olden days, now scientists believed that there are two types of organic compounds. Okay, therefore, in olden days, scientists were believed that there are two types of compounds. One, organic compounds, and another one is inorganic compounds. Right. So there are two types of compounds, one organic and inorganic compound. And so what are the organic compound? Organic compounds are, they believed that the compound which are obtained from living organisms, the compounds which are obtained from where? Living organisms, like the wastage of the plants, even dead bodies of the animals, etc., called what? Organic compound. And what are the inorganic compound? Inorganic compound is the compounds which are obtained from the usually an earth crust. The compounds which are obtained from the earth crust called inorganic compound. So this was their idea on this chemistry. Therefore, tell me, organic compounds are what? The compounds which are obtained from what? The compound which are obtained from living organisms like plants, the wastage of plants and dead bodies of animals, etc. And inorganic compound, the compound which are obtained from earth crust. Called inorganic compound. Okay, now, so therefore, then later the scientist called Berzelius. So to explain the organic and inorganic compound, Berzelius given the theory called vital force theory. Therefore, the vital force theory is the first theory which explains about organic compound. So therefore, next theory is vital force theory. Okay, this vital force theory proposed by it was proposed by Berzelius. Then what actually Berzelius proposed? See, Berzelius proposed that organic compounds can be obtained from only living organisms because they are having some mysterious forces or some like vital forces. Organic compounds having some vital forces, they can be obtained from only living organisms. They cannot be from inorganic compound, they cannot be prepared in laboratory. This was the statement of Berzelius. Therefore, so what Berzelius proposed? Berzelius proposed the same thing, whatever we have written here. Organic compound is nothing but they are obtained from the living organism. Here also he proposed the same thing. But what he added is, why the organic compound is prepared from only only living organisms, because living organisms having some unknown forces, some vital forces, okay, some mysterious forces. Because of those forces, so only living organism can be produce the organic compounds. That was his statement. Therefore, tell me, vital force theory was proposed by Berzelius. He proposed that organic compound can be prepared from only where? They can be prepared from only living organisms, because they are having mysterious forces or vital forces. Some mysterious forces or vital forces. Okay. But later scientists called Holar. So Holar is the chemist actually. Later the chemist called Holar, he was prepared the urea in laboratory. Actually it was accidental. See, Holar is the chemist. He was actually, he was doing experiment with ammonium cyanide, right? He was doing some experiment with ammonium cyanide, but accidentally he got when ammonium cyanide is heated, he got urea. That means the urea is the first organic compound prepared in the laboratory. Then when he was prepared urea, then all these theories get vanished, because so far what scientists believed, they believed that organic compounds are the compound, they can be obtained only from living organisms. They cannot be prepared in laboratory and they cannot be obtained from inorganic compound. But Holar is the chemist. He was prepared the urea from ammonium cyanide. On heating ammonium cyanide, he got urea. Therefore, so the reaction is actually potassium cyanide, KCNO. It is reacts with ammonium sulfate. He got ammonium cyanate, okay, plus K2SO4. Now this ammonium cyanate on heating, which gives urea. So therefore this is the first organic compound prepared in laboratory. By whom? Holar. So therefore Holar is the chemist, actually German chemist. So he prepared the urea from the ammonium cyanide on heating. Okay. Then now after preparation of urea, then now scientists got confusion. Now earlier they felt that only organic compound can be prepared from, they can be obtained from only living organism, but it was not like that, because they can also prepare from ammonium cyanide is inorganic compound. By heating inorganic compound they got urea. Then after this there are many scientists prepared many organic compound. So firstly coal base prepared acetic acid in the laboratory, and Henel prepared ethyl alcohol in the laboratory. Even Berthollet prepared methane in the laboratory. So therefore different scientists prepared the different organic compound after Holar. But Holar is the first chemist. He was prepared urea, that is first organic compound. Okay. So therefore now it is clear that organic compound not only obtained from living organisms, they can also be prepared in laboratory, that is they can be prepared from inorganic compound. Now what may be the definition of organic compound, organic chemistry? Then scientists were trying to give the definition of organic compound, organic chemistry, and a group of scientists suggested that the definition of organic chemistry, organic compound is the study of carbon and its compound is called organic chemistry. So therefore, is it true? Study of carbon and its compound called organic chemistry. See, some extent, all right, study of, because all organic compounds are carbon compounds. Can you tell me any organic compound which is not having carbon? No way, right? All organic compound must have carbon. Other than carbon, there may be a hydrogen, oxygen, sulfur, nitrogen may be there, may not be there, but carbon must be there. That means, so this is some extent all right, because carbon and carbon compounds are organic compound, organic chemistry. But at the same time, there are some compounds having carbon, but they are not organic compound. What about, for example, CO2, right? CO2 is a carbon compound. Is it organic compound? No. Carbon monoxide, it is a carbon compound. Next, even sodium carbonate, sodium bicarbonate, even, yeah, carbonates, bicarbonates. So carbon compounds, even oxalate, sodium oxalate, Na2C2O4, carbon compound, but it is not an organic compound. That means there is a limitation. That means all organic compound, all carbon compounds are not organic compounds. Therefore, this definition also 100% not suitable. Therefore, later a modern definition is given for organic compound, organic chemistry. Therefore, from here onwards, whatever we study, that is modern definition and modern classification, everything important. Okay, so what is the modern definition for organic chemistry, organic compound? So organic chemistry is, or organic compound is nothing but hydrocarbon and their derivatives. Hydrocarbon and their derivatives are called organic compound. The study of hydrocarbon and their derivative is called what? Organic chemistry. Therefore, now this is the truth, because hydrocarbon and their derivatives. So what are the hydrocarbon? For example, you can take methane. Methane is a hydrocarbon, and in methane you just replace one hydrogen with one OH, right? So replace one hydrogen, that means plus OH minus H, remove the one hydrogen, add one OH, what do you get? CH3OH. So methane is a hydrocarbon, methyl alcohol is its derivative. Therefore, organic compound all are like this only. So what are the organic compound? They may be a hydrocarbon or they may be a derivatives of hydrocarbon. Therefore, hydrocarbons and their derivatives are called organic compounds, and the study of this organic compound is called organic chemistry. So this is the modern definition. So therefore, what is the modern definition? Hydrocarbons and their derivatives. Hydrocarbon and their derivatives called organic compounds. Organic compound, comma, the study of organic compound is called organic chemistry. Like for example, methane, or else you can take ethane. Ethane, replace one hydrogen minus H, add one CN group, CH3, CH2, CN, right? You can add many more examples. So therefore, hydrocarbons and their derivatives both are called organic compounds. Okay, so this is the modern definition of organic chemistry. Next, but we know that in chemistry we have separate study of chemistry for carbon only. Okay, that is organic chemistry. In periodic table there are 118 element, right? Periodic table has total 118 element. Out of 118 element we have study of only one carbon is separate, that is organic compound, organic chemistry. Then what is the reason that we have separate study of carbon and its compound? Because carbon can form a huge number of compounds. There is an unlimited number of carbons, unlimited number of compounds. So carbon can form a large number of carbon compounds, right? So due to this reason, so we have separate study of carbon and its compounds, that is organic chemistry. Okay, Fine. Then what is the reason that carbon can form a large number of compounds? So it is not possible for remaining elements. So there are three reasons. That means carbon can form a huge number of carbon compounds. It is due to one, tetravalency. The valency of carbon is 4. Next, second one, catenation. Right? So carbon has a property called catenation. And third one is isomerism. So due to isomerism also, it forms a huge number of carbon compounds. So therefore, next is carbon can form a large number of carbon can form large number of organic compounds or carbon compounds. It is due to what is the reason? One, tetravalency. It is due to one, tetravalency. Tell me. So what is the meaning of tetravalency? So the valency of carbon is 4, right? So valency is only 4. It never form 5 bonds. Yes or no? There may be a possibility of 2 bond, 3 bond, that is unstable. Sometimes stable also. But its valency maximum 4. Can expand its valency beyond 4? No. Right? Then tell me, is it tetravalency is only the reason for the formation of many compound? If tetravalency is only reason, then what about sulfur? Sulfur has hexavalency. It can form 6 bonds? No. Sulfur can form 6 bonds, phosphorus can form 5 bonds. Right? Isn't it? Chlorine can form 7 bonds. Xenon can form 8 bonds. Then they could have formed many compounds, no? Right? That means, so tetravalence is the not only one reason for what? Formation of many organic compound. It is one reason, not only it is a single reason. So therefore, there is a one reason for tetravalency. So therefore, now tell me, the valency of carbon is 4. Tetravalence is, valency of carbon atom is 4. Can you tell me why the valency of carbon atom 4? We know carbon atomic number is 6, right? Its electronic configuration 1s2, 2s2, 2p2. So what is its ground state electronic configuration? Ground state electronic configuration. In ground state 1s2, there is a 2 electron in 1s orbital, and 2s2 there are 2 electron in 2s orbital, and 2p2 in p subshell there are 2 electrons, like this. This is a ground state electronic configuration, but it is undergo excitation. Tell me, in excitation 2s electron can jump from low energy level to high energy level by taking a minimum energy. By taking a minimum energy, so therefore here 2s electron can jump from 2s to 2p2. Therefore, which is called a excited state. Which excited state? It is a first excited state electronic configuration. In first excited state electronic configuration, 1s will be same, right? 2s become what? 2s 1 electron, and 2p2 become 2p3. 1 1 1. Okay, now tell me, in first excited state carbon has how many number of unpaired electrons? So it has, this is 1, it is 2, 3, 4. Therefore in excited state, first excited state, it has 4 unpaired electron in valency shell. It is a 2s, both are valency only. In valency shell it has 4 unpaired electron. Therefore, due to presence of 4 unpaired electron, so these 4 unpaired electron make use of forming 4 bonds. That's what. So carbon can form 4 bonds with either 4 carbon atom or other with any other element. So this is the reason carbon has 4 valency. tetravalency, right? Then since carbon has tetravalency, so here onwards we write like this, carbon 4 bonds. Okay, so it is a 2 hands 2 legs. Okay, so innond tara ee tara itre chana kansala idbadu. Okay, that is next is second property is, second important characteristic is catenation, right? So carbon has the property called catenation. What is catenation and it's important? It is a catenation is the self linkage property of carbon atom, right, to form what? A long either open chain or a closed chain also, right? The self linkage property of the carbon to form a long straight chain or a cyclic ring is called what? Catenation. So due to catenation, a carbon can link it with unlimited number of carbon atoms like this, right? It may be even cyclic also, like this, cyclic also possible, open chain also possible, right? So this property is called catenation. So therefore the self linkage property of carbon to form self linkage property of carbon to form long open chain or cyclic ring or cyclic ring called catenation. Okay, there is another question. Now alright, catenation is a self linkage property of carbon. That means carbon atom can link it with other carbon atoms, not only 1 2, it is many, like this. So one carbon atom, other carbon atom, like it link with many carbon atom, it form a long chain. Is it property of only carbon? Can other also having catenation? Yes, silicon also has, right? Silicon also has catenation. One silicon atom also bonded with many silicon atoms. No, we have silanes, right? Silicones, compounds are there. So silicon also has catenation property. Even sulfur also. Sulfur can form the S6 now. S8 now. It is also catenation property. One sulfur atom, it has total how many chain? 8 sulfur atoms. And phosphorus P4. It is also catenation property. But compared to all these elements, the catenation property of the carbon is highest. Carbon has highest catenation property among 118 elements. That is why. There are two reasons, right? The highest catenation property of carbon is due to this carbon-carbon bond strength. It has highest or strongest carbon-carbon bond strength due to strongest carbon-carbon bond strength. And another reason is CC bond strength. Carbon-carbon bond strength is almost equal to carbon-hydrogen bond strength and carbon-halogen bond strength. So therefore there are two reasons. So carbon has catenation property because it is due to strongest carbon-carbon bond. The bond strength of carbon-carbon is very high. And not only that, the CC bond strength, carbon-carbon bond strength is also almost equal to carbon-hydrogen bond strength, carbon-halogen bond strength. So because of this reason, carbon can form a long chain. For example, what property, how does this property help for this catenation? Okay, you generally usually what happen, if carbon do not have catenation property, it cannot make able to form a long chain, right? Because if this carbon try to form the long chain, there is a easy breaking, no? If any element form a long chain, the breaking become easy. Yes or no? Therefore, it could have break easily. It cannot be broken easily because it is a carbon-carbon bond strength. The carbon-carbon bond strength is strong here. Whatever the strength is there, here also same strength will be there. Right? It's just like what is a chain. Okay, how the linkage will be there, like this. So here also all the bond strength are very strong. Not only carbon-carbon bond strength, even carbon-hydrogen bonds also strong. If this bond is not strong, then this bond, this CH bond cannot be formed so stable. So therefore, what strongness this carbon-carbon bond is there, the same strong carbon-hydrogen bonds also be there. Even carbon-halogen bond also be there. So therefore, because of this reason, so even it form a 1000 carbon chain, this stable. Okay, so that is called catenation property supported by these two. One is a strength of carbon-carbon bond, highest strength, and carbon-carbon bond strength, which is also almost equal to carbon-hydrogen, and carbon-halogen bonds also same stable, same strength. So therefore, these two properties makes so catenation become easy. Okay, so therefore, because of catenation, it form a large number of carbon compounds. Next, third property is isomerism. So here, the isomerism is the property of covalent compounds. So usually covalent compounds are covalent bond. The molecule which are having covalent bond, even coordinate covalent bond, can exhibit isomerism. Yes or no? Have you studied isomerism ionic compound? ಓದಿದ್ರಾ? ಐಸೋಮರಿಸಮ್ ಬರಲ್ಲ, ಐಸೋಮಾರ್ಫಿಸಮ್ ಬರುತ್ತೆ, ಬೇರೆ ಇದೆ, ಬಟ್ ನಾಟ್ ಐಸೋಮರಿಸಮ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ NeACl. NeACl is an ionic compound. What is isomerism of NeACl? We will write Cl in A. Is it meaningful? No. So therefore, ionic compounds do not exhibit isomerism. Okay. To exhibit isomerism, there is one property. Covalent bond is a directional nature. Covalent bond has particular direction. Therefore, the bond which has particular direction, so they can form the isomerism. For example, covalent bond is directional nature. For example, if you see the carbon-hydrogen bond, this bond is in particular direction only. If you take ionic bond, what is the meaning of ionic bond? In solids, in case of solid we have studied NaCl. In NaCl, one Na plus surrounded by how many Cl minus? 6 Cl, no, coordination number 6, 4, 5, 6 Cl. 1 Na plus surrounded by 6 Cl minus. Is it in one direction? In all direction? In all possible directions. That means the force of attraction between 1 Cl Na plus in one direction, all direction. In all possible direction. It means there is a force of attraction between cation, anion, not in one direction. It is in all direction. That's what ionic bond is a non-directional. It has no particular direction. Whereas covalent bond is particular direction. Coordinate covalent bond, that also has particular direction. Therefore, the compounds having covalent bond and coordinate covalent bond can exhibit isomerism, but ionic bond do not. Therefore, here our organic compounds having which bond? Covalent bond. Since they have covalent bond, they exhibit isomerism. So what is isomerism? In detail we have separate concept only, separate topic only, we will study. Therefore, due to isomerism also, organic compounds have organic, carbon can form a large number of compounds. Okay. These are the four reasons for what? Carbon can form a large number of organic compounds, carbon compounds. Okay. Next is right. To understand organic chemistry, nature of organic compound, first of all we need to understand hybridization. Okay. What is hybridization, and particularly hybridization of organic compounds? Okay. Next, right? Hybridization. So what is hybridization and hybridization of organic compound? Hybridization. Tell me. So what is the definition of hybridization? Hybridization is it is the process of intermixing of orbitals, no? The process of intermixing of orbitals of same atom or different atom? Same atom. The process of intermixing of orbitals of same atom having approximately same energy to form equal number of identical orbitals called hybrid orbital, and this process called what? Hybridization. Therefore, in hybridization you need to remember 2-3 important points. One, hybridization nothing but it is a process of intermixing. Like you take, for example, take S orbital, take P orbital, take D orbital, you just take in a mixer and grind it, mix ಮಾಡಿ. ಓಕೆ, ಏನಾಗುತ್ತೆ? ಮಿಕ್ಸ್ ಆಗುತ್ತಾ? ಮಿಕ್ಸ್ ಆಗಿ ಒಂದು ಯೂನಿಫಾರ್ಮ್ ಆಗಿ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತಾನೆ. This is also same. Hybridization also we do same thing. We take S and P, D orbital, different orbital, and we intermix it, right? And when you intermix, you will get identical orbitals. That too, same number of identical orbital. Those orbitals are called hybrid orbital, and the process is called what? Hybridization, right? So therefore, now here important is whether hybridization takes place in same atom or different atom. For example, it is a methane. Okay. If I say carbon atom undergo sp3 hybridization, sp3, what is the meaning of that? Whether only carbon orbitals undergoing hybridization or carbon hydrogen undergo hybridization? It is only carbon atom. The orbitals of the carbon atom only undergo hybridization. It means the process of intermixing of atomic orbital of same atom. Okay, it is not that like it is not overlapping. Overlapping is different. Overlapping means the carbon orbital overlap with hydrogen orbital. That overlapping is different. This is what intermixing. Intermixing of what? Only atoms of the orbitals of the same atom. Okay, if I say sp3 carbon means only carbon orbital undergoing sp3. There is no involvement of hydrogen orbital. Okay, therefore the process of intermixing of orbitals of same atom having approximately same energy to form equal number of identical orbital called hybrid orbital, and the process called what? Hybridization. Right, 2-3 important points. The process of intermixing of orbitals of same atom. The process of intermixing of orbitals of same atoms having approximately same energy. Approximately same energy to form equal number of identical orbitals. Equal number of identical orbitals called identical new orbital. Equal number of identical new orbitals called hybrid orbital. Called hybrid orbital, and this process is called hybridization. And this process is called hybridization. Okay, and this process is called hybridization, right? Next is types of not types, hybridization organic compound, right? We want to study hybridization in organic compounds. Hybridization in organic compounds. Okay, hybridization in organic compound, that means carbon compounds. Okay, right. See, in organic compounds, carbon atom undergo usually three type of hybridizations. In organic compounds, a carbon atoms can undergo 3 different type of hybridization. What are the 3? 1, sp3 or sp, sp2 sp3. Other than this, any other possibility? No. That means in organic compounds, carbon atom can undergo, right on. In organic compound, carbon atom can undergo, in organic compounds, carbon atom can undergo 3 types of hybridizations. 3 types of hybridizations, that is sp, sp2, sp3. Okay, sp, sp2, sp3. Now tell me, usually let us take alkane carbon and alkene carbon, alkyne carbon. Tell me, alkyne carbon. Can you tell me, in alkane carbon, what is hybridization? So in alkane carbon, it is always sp3. In alkene carbon, sp2. In alkyne carbon, sp. Yes or no? For example, let us take alkane carbon is CH4 or CH3, CH3. Tell me, what is the hybridization of CH4 or CH3? Both are sp3. Here also it is sp3, it is also sp3. Alkene carbon, CH2 double bond, CH2. So what is the hybridization of each carbon? If there is a double bond, if the carbon having double bond, so you need not to worry, need not to think of it, you just write sp2, sp2. If the carbon has triple bond, CH triple bond CH, then each carbon undergo what? sp and sp. Okay, but along with this you need to remember carbocation, carbanion. In organic chemistry we study alkane, alkene, alkyne carbon. Along with these 3 we also study carbocation. What is a carbocation? Or it is also called carbonium ion. Carbonium ion. It was the previous CT question. What is the hybridization of carbocation? So carbocation is carbon carrying positive charge. It is always sp2. Okay. When the carbon carry positive charge, sp2. For example, CH3 plus sp2 or CH3 CH2 plus, it is also sp2. Next, if the carbon carry positive charge called carbocation, carbonium ion. If the carbon carry negative charge is called carbanion. Carbanion. So what is the hybridization of carbanion? It is sp3. Okay, so therefore in organic compound alkane, alkene, alkyne, along with these 3 carbon we also study carbon positive and carbon negative. Here is like for example CH3 negative, it is sp3. Okay, we have carbon free radical and even carbon having 2 bonds, that is carbenes. We study carbene, carbene free radical separately. Okay, fine. This is hybridization. Now but the question is how to calculate the or how to identify the hybridization. So therefore hybridization can be identified, actually it is by VS-EPR theory, valence shell electron pair repulsion theory. There is a theory called VS-EPR, valence shell electron pair repulsion theory. By using this we can identify the type of hybridization, even we can identify the geometry also. Okay, but we cannot use that theory here. It takes time writing and all, it requires much more time. Therefore now we have shortcut method to identify the even hybridization. To identify the hybridization, first of all we should know number of hybrid orbitals. Okay, so therefore to take this tabular column, number of hybrid orbital and type of hybridization. type of hybridization. If you know the number of hybrid orbital in a given atom, that is related to type of hybridization. If the number of hybrid orbitals are 2, it is always sp. If the number of hybrid orbitals are 3, it is sp2. If it is 4, sp3. Okay, we want only 3, about these 3 only. Okay. So therefore, if the number of hybrid orbitals are 2, it is always sp. If the number of hybrid orbitals are 3, sp2, 4, sp3. But the question is, how to calculate number of hybrid orbitals? Then, is there any shortcut method or formula? Yes, there is a formula. Number of hybrid orbitals equals to, right? It is number of hybrid orbitals equal to number of sigma bond plus lone pair. Okay, you take sum of sigma plus lone pair. Right. So calculate the sigma bond, calculate the lone pair, which gives nothing but number of hybrid orbitals. Okay. For example, let us take organic compound methane. Methane, right? Can you tell me, methane central atom is carbon. I wanted to know carbon hybridization. Okay, tell me, in carbon there are how many valence electron? Carbon belongs to 14th group. It has 4 valence electron. 1, 2, 3, 4. You just write valence electron 4. Next, but we also know that one valence electron, one unpaired electron can form one sigma bond. There are how many hydrogen? 4. It means this one lone pair, one unpaired electron can form one hydrogen bond, one bond with hydrogen, another bond. Okay. So is there any electron left on carbon? No. Therefore, now tell me, I want number of hybrid orbital equal to how many sigma bond? 1, 2, 3, 4. 4 sigma bond. How many lone pair? 0. Sorry, 4 sigma bond plus 0. That is 4. So therefore, number of hybrid orbitals are 4. 4 means what is hybridization? It is sp3. So simple. Right. Number of unpaired electron?
Suppose unpaired electron or coordination bond present.
Let it be whatever bond is present. If there is a unpaired electron, you got a unpaired electron, that we have exceptional cases. If there is a unpaired electron, we have some exceptional cases that we will do it later. In chemical bonding will barutte. Like you are telling free radical. Okay, like free radical carbons are there. They have unpaired electrons. In case of unpaired electron, there is a 2 possibility. One, they may have double bond. It means 2 bonds. They may have triple bond. They may have single bond. If there is a single bond with 3 electron. Usually, we take a bond with 2 electron. Usually, bond is formed with 2 electron. But there are some species having, like for example, NO. Okay, tell me, nitrogen has how many valence electron? 15 group, 5 no? 5. Okay, there is a 5 valence electron, but here NO. This NO usually forms like this double bond, no? Now, there are how many unpaired now? 1, 2, 3. Okay, therefore, in this case, what happened? This one more electron involved here. It means a sigma bond is formed by 3 electron. That is called a 3 electron bond. Okay, that exceptional cases we study in chemical bonding. The topic we have separate hybridization, there we study. Here need not to discuss. We study here only organic compound. We apply the hybridization concept for organic compound only. Okay, fine. So therefore, now it is sp3. For example, now let us take CH2 double bond CH2. Come on, tell me. So what is the hybridization of 1 and 2 carbon? So it is, we know sp to sp2. Then calculate the hybrid orbital. To calculate hybrid orbital, you tell me, carbon atom has how many valence electron? 4 no? 4 electrons like this, 1, 2, 3, 4 electrons. Okay, then tell me, then there are 2 hydrogen, no? two hydrogen form two bonds like this. There are two bonds, no, one sigma bond, one pi bond, and another carbon. It is also having same bonds, same electrons like this. Therefore, they form sigma bond, one sigma, one pi bond, and two hydrogen, two sigma bonds formed. Now we want on this carbon, tell me, on this carbon, calculate the hybrid orbital. Number of hybrid orbital equal to sigma bond. How many sigma bond? It is 1, it is 2, this is 3. Is another is pi bond? No. In double bond only one sigma, one is pi. In triple bond one sigma, 2 pi. Therefore, number of hybrid orbital equal to sigma bonds are 3. Lone pair is 0. Therefore, it is a 3. It means it is a sp2. Similarly, this is also sp2. Therefore, wherever carbon has double bond, sp2 only. Next, one more example. Let us take CH3 plus CH3 minus. Tell me. Now, what is the hybridization of carbocation? You remember, carbocation always sp2. Okay. It is sp3, but there are some exception for this. I'll tell you exception later. But remember, when carbon has negative sp3, positive sp2. How and why? Again, calculate number of hybrid orbital. Now, to calculate number of hybrid orbital, you take first carbon, its valence electrons are 4. Okay. Then tell me, this carbon has which charge? Then how do you get positive charge? By losing one electron. Therefore, carbon has actually 4 electron. It lost 1 electron because positive charge. It lost 1 electron and there are 3 hydrogen. So 3 hydrogen form 3 sigma bond. Therefore, number of sigma bonds are 3. Then, so number of hybrid orbital equal to 3 plus 0 equal to 3, that is sp2. Yes or no? Similarly, CH3 minus. It is also similar. Carbon. So carbon has 4 valence electron because tetravalence and moreover 14th group element it is. Okay. Then, and there is a negative charge. Do you know what is the meaning of negative charge? Gain of 1 electron. Actually 4 are there, but it is gain 1 electron. Then there are how many hydrogen? 3. So 3 hydrogen now can make 3 sigma bond with 3 electrons. Now still there is a how many lone pair? Lone pair I am telling, not electrons. Pair and red tane. Okay. So therefore, now tell me, so sigma bonds are 3. Lone pair is 1. Therefore, number of hybrid orbital equal to 3 plus 1 equal to 4. That is sp3. Okay. So in this way, you can calculate the number of hybrid orbital and type of hybridization. Okay. Now write down question. Identify the hybridization of C1, C2, C3, C1, C2, C3 and C4 carbon atoms in the following. Identify the hybridization of C1, C2, C3 and C4 carbon atoms in the following. CH2 double bond, CH, this is 1, 2, 3, 4, next 2, one, 2, 3, 4, 5. 1 2 3 4. Two, three, 4, 5. Okay. Right. So identify the hybridization of C1, C2, C3, 4, C5 carbon atoms now. Tell me for first one C1, C2, C3, C4. Here 1, C2, C3, C4. Here also C1, C2, C3, C4. C1, C2, C3, C4. C1, C2, C3, C4. Come on, tell me. So what is the hybridization of first carbon here? sp2. No, here sp3. sp3. sp3 because alkane carbon. Next is, say if the carbon has double bond, it may be with other carbon, other oxygen, whatever it is. On carbon, if there is a double bond, it must be sp2. For which atom you need not worry. Next 3 is sp2 only because there is a double bond now. So don't confuse. This carbon has one side single bond, right? Other side is double bond. So therefore you should take this double bond only, alkene carbon only. Therefore fourth carbon also sp2, third sp2. Next, tell me here C1 sp. Second one sp, triple bond. Third one sp2. Fourth one sp3. Next first one it is sp2 because carbocation. Second one sp3. Third one sp3. Fourth one sp3. All sp3. Next C1 here, tell me. sp3. Next sp2. sp. Tell me. It is second carbon. See, C1, C2, C3, C4. C1 carbon is sp3. C2 carbon is sp2. Now tell me, what about C3 carbon? sp only. Why? It is sp only because you calculate the number of hybrid orbital on this carbon. Tell me, on this carbon hybrid orbital equal to sigma bond. How many sigma bond? 1, 2. 2 sigma bond. Okay. Plus any lone pair? Lone pair is 0. So therefore it is only 2. If the hybrid orbitals are 2, it is sp hybridization. Therefore it is 2. sp. Next is sp2. And moreover, remember, if two double bonds, like double bond on two double bond present consecutively, what is that? Continuously on carbon, which is called alkyne carbon, which is equals to alkyne carbon, sp hybridization. Next.
Sir, fourth carbon CH2.
On fourth carbon sp2 ಬರುತ್ತಾನೆ. CH ಬರುತ್ತೆ. Okay. Balance. Okay, fine. Next is, here tell me, on this carbon C1 is sp because triple bond is there, no? Okay, sp. Next C2 sp3. C3 sp3. C4 sp3 only. Okay. Okay, next write one note. Take one note. If negative charge or lone pair electron, if negative charge over or lone pair electrons or conjugation with pi electrons, then these lone pair or negative charge, then these lone pair over or negative charge should not be considered in hybridization. Then these lone pair or negative charge should not be considered in hybridization. Should not be considered in hybridization. Okay, it means if the negative charge or even lone pair, if the negative charge on lone pair conjugation with pi electrons, if any one of these is conjugation with pi electron, then these lone pair negative charge should not be taken in hybridization. Means for example, that is very important, you will get application bada important prati time alli barutte bara clean agi artha madಕೊಳ್ಳಿ. If for example let us take CH3 CH2, it is NH2. Okay, there is one lone pair on nitrogen, we know it. Now I want what is the hybridization of this NH2 group. Tell me, what is hybridization? Calculate hybrid orbital. Hybrid orbital equal to sigma plus lone pair. How many sigma bonds are there? This is one sigma bond. There are two hydrogen. 3 sigma bond. Plus lone pair is, there is one lone pair, 1. It is 4. That means this nitrogen is undergo sp3 hybridization. This is as usual, we know it. But now for example, let us take CH2 double bond CH NH2. Now tell me, now in this case what is the hybridization of same NH2? Is it sp3 or not? It is not sp3. The reason is, that's what, see, if the lone pair are negative charge, conjugation with what? Pi electron. You see, lone pair sigma bond pi bond sigma bond lone pair, how they are? Conjugation, right? That is the meaning of conjugation. No, benzene is a conjugation pi bond, right? What is the meaning of conjugation pi bond in benzene ring? Sigma bond pi bonds in alternate positions, right? Pi bond, then sigma bond, pi bond, sigma bond are alternate positions. The meaning is same here in conjugation. Which are conjugation? Lone pair sigma and pi, and means lone pair and pi bond both are in conjugation. If they are conjugation, they involved in resonance, because this lone pair form the pi bond here, this pi bond shifted here. Therefore tell me, there is a lone pair, but that lone pair forms what? Pi bond? No. Then it becomes what? CH, it is a pi bond, NH2 become NH2 plus. Okay, barutta? Yes or no? Artha agilla? Then now tell me, okay, I am not bothering about this conjugation, I am not bothering about what is it? Resonance. I want hybridization. What is the hybridization of this nitrogen? Tell me. To calculate hybridization, there is only one method, hybrid orbital. You just calculate hybrid orbital. So number of hybrid orbital equal to sigma plus lone pair. Sigma are 2 plus 1 3. But whether I should take lone pair? Actually there are lone pair. Whether those lone pairs are localized or delocalized? Very good, delocalized. Here is localized. They are not in movement. They are in movement. Why they are movement? Because they are conjugation. Due to conjugation they are involving resonance. Right? That's what you should not take. It means if the electrons are delocalized, you remember like this. If electrons are delocalized, they should not be involved in hybridization. Okay. Okay, therefore they cannot be taken in hybridization. That means it becomes 0. Avagena agutte 3. That means it is a sp2 agutte. Andre lone pair resonance ಅಲ್ಲಿ involved ಆದರೆ they do not involve hybridization. If electron involved in hybridization, they do not involved in resonance. See, if the lone pair involved in hybridization, they do not involved in resonance. If lone pair involved in resonance, they do not involved in hybridization. It vice versa. Here is electron involved in hybridization, but there is no resonance. Here resonance, these electrons do not in hybridization. That's what this is a sp2, that is sp3. One more example. I hope it is clear. Take one more example, you tell me answer. Let us take CH3, CH2, CH2 negative. Same example, CH2 double bond, CH, CH2 negative. Come on, tell me. So what is the hybridization of this? What is the hybridization of this carbon? We calculate sigma bond, sigma 1, 3 plus 1 lone pair, no? Okay, it is sp3, tane? Or sp3. Fine, tell me this is. It is also look like sp3 because the reason, but not. The reason is this lone pair involved in resonance. Okay, therefore you will get resonance structure, no? CH2 become negative, then CH double bond CH2. Okay, so therefore now what is hybridization of this carbon? This carbon only 2 sigma bond, 1 sigma bond, 3 sigma bond, lone pair should not be taken, it become sp2. One more example, you tell me this. It is sp2. Why? This lone pair and see, lone pair pi bond both are in conjugation. Lone pair sigma bond pi bond. So there is a resonance is possible. Therefore, usually carbanion is sp3. Usually carbon containing anion sp3. But in these cases it is sp2. There is exception. Okay, take. Next, calculation of next, right? Taken or not? Next is calculation of number of hybrid orbital and number of pure atomic orbital. Let quickly. So calculation of number of hybrid and pure also called unhybrid orbitals. How to calculate hybrid and unhybrid orbital? It is very simple. It was previous question. It's given in a CD. Okay, first let us take simple example, methane. Tell me, in methane how many hybrid and how many unhybrid orbitals? So how to calculate hybrid? See, to calculate hybrid orbital, you first calculate hybridization. What is the hybridization of carbon here in methane? sp3. Tell me, if any atom undergo sp3 hybridization, it has how many hybrid orbitals? 4. In sp3 hybridization there are 4 sp3, no? Do you remember like this? Carbon undergo sp3 hybridization, it form 4 sp3, 1, 2, 3, like this, no? 4. These 4 sp3 oriented 4 corners of the regular tetrahedron, like this. That means carbon undergo sp3 hybridization, it has 4 sp3, right? Therefore it has 4 sp3 or number of, right, number of hybrid orbital equal to 4, that is 4 sp3. Next, number of pure orbital equal to How many pure atomic orbital? Okay, now carbon has sp3, it has no pure orbital, all sp3 only. Then, but carbon surrounded by how many hydrogen? Right. Then we know that each hydrogen has one s orbital like this. It overlap, no? Like this. That means this s orbital overlap with the sp3. This s orbital is hybrid or pure? Pure. That means only central atom undergo hybridization. Central atom is carbon. Carbon undergo hybridization, but not hydrogen. Therefore, each hydrogen has one s orbital. There are 4 hydrogen has 4 s orbital. Therefore, number of pure atomic orbitals are how many? 4. Which 4? There are 4 1s orbitals of what? Hydrogen atom. Yes or no? That's it. Sometimes they ask ratio. Okay. So what is the ratio of hybrid to unhybrid? Ratio of hybrid to unhybrid orbital. Hybrid is, tell me, 4. Unhybrid is 4. Ratio is 1:1. Yes or no? Next, 2. Quickly. Ethane. Tell me, I want number of hybrid orbital. To calculate number of hybrid orbital, you first calculate hybridization. This is sp3. This is also sp3. Tell me, hybrid orbitals equal to how many number of hybrid orbital equal to how many? Tell me. It is sp3. Notice, one carbon sp3 means how many sp3 is there? 4. 4 plus 4? 8. There are 8 sp3 hybrid orbitals. Next, I want pure orbital. Pure atomic orbital, that is also called unhybrid. So how many? So each hydrogen has 1. 3 plus 3? 6. Therefore, it is 6 s orbitals. They are pure atomic orbitals. So here hydrogen do not undergo any hybridization. We know it because only one central atom undergo hybridization. Therefore, what is the ratio? The ratio of hybrid to unhybrid, that is 8/6. It means 4:3. Next, similarly, ethene propene. You calculate number of hybrid and unhybrid orbital ethene and propene. Example 3. Right, ethene, CH2 double bond, CH2. Come on, tell me anybody. How many number of hybrid orbitals? Number of hybrid orbital equal to. So we should know that what is the type of hybridization? sp2. It is also sp2. So each sp2 carbon has 3 sp2. 3 plus 3? 6. So therefore 6 sp2 hybrid orbitals. But how many pure orbitals? Pure atomic orbitals. Tell me anybody. Pure atomic orbitals. Drushti. Huh?
5.
Pramod. How many? There are how many hydrogen? 2 and 2. 4. Is it 4 only? Where 5? Pi. Pi bond is there. What pi? What pi andre? So there are pure atomic orbital is, of course, 2 plus 2, 4 s orbital will be there. 4 s orbitals. But along with s orbital, do you know, if carbon undergo sp2, it is like this. It has 1 sp2, second sp2, third sp2. Yeah, it is also one carbon. 1 sp2, second sp2, third sp2. If carbon undergo sp2, each carbon has one unhybrid p orbital which is perpendicular to this plane. If it is a plane, there is a one like this, above the plane, below the plane. So ಆ ಥರ ಡ್ರಾ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಈ ಥರ ಡ್ರಾ ಮಾಡ್ತೀನಿ. This is what? It is a pure p orbital. It is also has pure p, no? It is also pure p atomic orbital. ಹೌದು ತಾನೆ? Now these two overlap. Due to overlapping, these will get pi bond. Therefore we want total number of unhybrid orbital. Therefore it is a 4s orbital plus 2 p orbitals. Therefore total 6. Got it? Then what is the ratio? So the ratio of hybrid to unhybrid. Hybrid is 6, you know. Unhybrid is 4 plus 2, 6. Okay, it is 1:1. Bigger. One more example. Calculate hybrid and unhybrid orbital. To calculate hybrid orbital, it is calculate first identify hybridization. Both are sp, no? Therefore hybrid orbital is equals to each carbon undergo sp. It means if carbon undergo sp, how many hybrid orbital? 2. 2 plus 2, 4. Therefore there are only 4 sp hybrid orbitals. Then what about pure orbital? Pure atomic orbitals are how many? 1 plus 1, 2. Of course 2 hydrogen orbital plus 2 means 2s orbital. Okay, plus. Now each carbon has 2 unhybridized p orbital which are perpendicular to each other. Yes or no? So that means if carbon undergo sp, this is one sp, it is another sp. Take another carbon, sp overlap, it is also sp, it is also sp. When the carbon undergo sp hybridization, then each carbon has 2 unhybridized p orbital. Okay, again they are perpendicular actually. So one is above below, one is up and down comes. So therefore above below ಬರೆಯೋಕ್ಕಾಗಲ್ಲ, ಹಾಗಾಗಿ ಈ ಥರ ಬರಿತೀನಿ. They are unhybrid. It is also unhybrid. Therefore it is a pure p orbital. It is also pure p orbital. There are also 2. That means these pure 2 orbitals, no, they actually overlap like this. Okay, so they form how many pi bond? 1 1 2 pi bond. So therefore how many p orbitals? 2 p. Therefore 2 plus 2, 4. Okay, so this is how you can identify, calculate the number of pure and okay. Quickly take one tabular column, you just calculate. One here is, take this tabular column, molecule. Tell me where ಎಲ್ಲಿ? 1 ಆಗುತ್ತಲ್ಲ, 2 ಆಗಲ್ಲ. 1 no 1 ಅಂದರೆ see, 1 carbon has 1, no, this carbon has 1 p orbital ತಾನೆ, this also has 1. ಎಲ್ಲಿ? ಓ 4 ಆಗ್ಬೋದು. ಯಾರು ಬೇಡ ಅಂದರೆ? ಓಕೆ 6 ಆಗ ಅಷ್ಟೇ ತಾನೇ. ದಿಸ್ ಕಾರ್ಬನ್ ಹ್ಯಾಸ್ 2, ದಿಸ್ ಕಾರ್ಬನ್ ಹ್ಯಾಸ್ 2, 4 ಕರೆಕ್ಟ್ ಓನ್ಲಿ. ಓಕೆ, ಬೇಗ ಬರ್ಕೊಳ್ಳಿ. ಮಾಲಿಕ್ಯೂಲ್ ನಂಬರ್ ಆಫ್ hybrid orbital, number of pure atomic orbital and ratio of hybrid to unhybrid orbital. Okay, write this.